So how do you combine those two together? If the base is the same, so the base is the part with the a, and you have exponents, we're trying to multiply them. Julia, what do we do to combine them together? Yeah, you add the powers. So we would still have a. That part isn't changing, but now we're adding the powers together. So m plus n. So it doesn't become 2a. You're just adding the powers together. The base doesn't change. So in the example underneath, we have x squared times x cubed. So the x stays the same. Julia, 2 plus 3 makes 5. So that would become x to the 5th. Because really, you're taking x times x times x times x times x. And if you combine all those together, there are 5 x's. So x to the 5th. The next one, we have the power of a power property. So power of a power property. Looks like a to the m, and then outside there's an exponent of an n. Anybody remember what you do with that? How do you simplify that, Connor?
Multiply them.
Yeah, so multiply them, we would just have m times n. So a power to a power, that's when you multiply the exponents together. So Connor, x cubed to the 4th becomes? X to the 12th. The third one is a power of a product, so kind of like the second one. But now we have a product in the middle, so we're taking a times b to the m power. Maddie, what do you think that looks like then? Yeah, so you take m to both of them, but it stays as an exponent. So it's like you're distributing the m through, but you're distributing it to the exponent. So it would be a to the m and b to the m. So again, they get the same exponent, but it stays as an exponent. It doesn't become that whole number of the base. So Maddie, if we have x cubed times y squared, and then both of those are squared, that would become? Yeah. So if you distribute the 2 to the exponents, you have x to the 6th and y to the 4th. So those three identities kind of dealt with the products of things. Looking at the next group here, this is the negative exponent property. So it says a to the negative m. Does anybody remember what happens when you have a negative exponent? So what does a negative power do? Odette? Yeah. So if we have a to the negative m, the negative exponent moves it down into the denominator and becomes a positive exponent. So we don't want to have a negative exponent. It's considered unsimplified. So the way we can make that exponent positive is by moving that whole part to the denominator of a fraction, place a 1 on top of it, and then our exponent becomes positive. So Odette, we have x to the negative 3 times y squared. So what would that look like?
Y squared over x.
Yeah, perfect. So this part here, x to the negative 3 becomes 1 over x cubed. But we still have that y squared. So the negative exponent part, you take that whole variable, you move it to the denominator, the exponent becomes positive. But then when you multiply these together, this is really y squared over 1. So we have 1 times y squared and x cubed times 1. So y squared over x cubed. The next property is the zero exponent property. What happens when you have anything to the 0 power? Julian? It equals 1. It doesn't matter what the number is. If anything to the 0 power is equal to 1. And you actually learned that back in 5th grade, which is kind of weird to think that's when you learned that property. But 5th grade is when you're taught about the 0 exponent property. Kind of, my daughter was, just kind of didn't get that. 0 exponent property, anything to the 0 power is equal to 1. The last two we have here is the quotient property. So quotient of powers. We have a to the m divided by a to the n. Will, what do you do when you're dividing? What do you do with those exponents? we do when we were multiplying? So look at the first one. When we were multiplying a to the m times a to the n, we added the exponents. So if you're dividing, what do you think you do? Yeah, you subtract the exponents. So this becomes a to the m minus n. It says a can't be 0, so you can't have a 0 there. And we'd have 0 divided by 0. That doesn't work. So we have x to the 5th divided by x squared. So if you subtract those, you get x cubed. And then the last one says a power of a quotient property. So a divided by b to the m power. Abby, what do you think happens there?
Does it distribute to both?
Yeah, it distributes to both of them. So just like the product, where it distributes to both, in a quotient, it does the same thing. So this would be a to the m divided by b to the m. And again, it says b cannot equal 0 because we can't divide by 0. So Abby, what happens with x to the 5th over y squared, and then all of that squared?
It's x to the 10th over y to the 4th.
Good. X to the 10th over y. So we're going to try and use those properties to simplify or evaluate, in this case, the numerical expressions. So the first one, we have 6 squared and then cubed on the outside. So kind of just think about, what does it look like? What's the property? How can we evaluate that? So what's the first thing that we can do with those exponents? Tatum, what can we do there? Multiply them. So this becomes 6 to the 6. All right, so evaluate means eventually we want to just find a numerical answer. So you probably don't know what 6 to the 6 is in your mental calculator, Tatum, huh? No, probably not. It's not one of those numbers you keep stored up into your brain up there. But Tatum, if you put 6 to the 6 in your calculator, 46,000, you said 656. So 6 to the 6 is 46,656. Again, not something that you probably have memorized. The next one, we have 4 to the 5th divided by 4 cubed. So Gavin, what do we do when we have 4 to the 5th divided by 4 cubed? And that gives us 4, and 4 squared is 16. That one we can do without using a calculator. Letter C, we have 4 to the negative 4. Mackenzie, what do we do with, or 7 to the negative 4, not 4 to the negative 4. 7 to the negative 4, what do we do there?
You'd have to make it 1 over 7.
So 1 over 7 to the 4th. And then if you just put 7 to the 4th in your calculator, because we don't want to get a decimal here, what is 7 to the 4th?
2,401.
21?
And 1.
Oh, 01. Gotcha. So we don't want to get a decimal, keep it exact. You're just placing that 7 to the 4th part in your calculator, you got the 1 on top. So 1 over 2,401. And then letter D here, we have 2 cubed divided by 3 squared, and then all of that is cubed. So Melanie, what would D look like?
2 to the 9.
Yep, multiply the exponents. So 3 goes with 3, and the 3 goes with the 2 in the denominator, so that becomes
3 to the 6.
good. So we have 2 to the 9th and 3 to the 6th. So you're multiplying the powers. And then, Melanie, what is 2 to the 9th?
Just wait.
And how about 3 to the 6th?
720.
Any questions on those 3? So again, no decimals, keeping them exact. Just evaluating the powers, keeping it as a fraction. So, looking at the next set of examples on the back page, now we're going to kind of work with properties of exponents, expressions, but dealing with variables and seeing if we can try and break those variables down. And it gives you like a little bit of a hint on the side as to like what we would want to think about first to try and break this problem down. So it has a power of a product property. So we have x to the fifth y squared, and then that's cubed. Because it's in parentheses, order of operations say we need to do parentheses first. The denominator has the x to the 15th and the y to the 8th, but that isn't in parentheses. So right now we just need to kind of focus on the top. So Holly, if we look at the top there and we evaluate the top with that cubed, what would the powers become? Good. And then on the bottom, we still have x to the 15th, but we have y to the 8th. So the denominator didn't change because it wasn't in parentheses. Can that be simplified any further? Is there anything else that we can do to simplify that? Gavin, what do you think? Yeah, the x to the 15ths cancel. They're exactly the same. So if you have 7 divided by 7, they would cancel. If you have x to the 15th divided by x to the 15th, they also cancel. They're the same value. Now we're left with these y's. So we still have y to the 6th divided by y to the 8th because the x is canceled. Can that be simplified any further? She said it would be 1 over y squared. And what'd you do with those powers? Yeah, you subtract the powers. Wherever the largest power is located, in this case it's in the denominator, that's where your variable remains. So you're taking the 8 minus the 6. The biggest power is in the bottom, so the simplified answer remains on the bottom. So your solution there, your simplified expression will be 1 over y squared. Questions? So if there are variables that are the same, we need to make sure we combine those variables together. The second one, we have a to the negative 4 over b squared, and that's raised to the second power. And it says first, again, we have the product of a product property. That actually should be product of a quotient property, not. Let's fix that there. So that's a power of a quotient property, not power of a product. If they're quotient, it's not something being multiplied. Probably copied and pasted instead of fixing it. So, Rebecca, what would that power outside do to the inside exponents? Okay, so we distribute to both of them. So that gives us a to the and b to the 4th. And then the next step says the negative exponent property. What does that mean you're supposed to do, Rebecca? Good. So she said a to the negative 8 gets moved to the bottom. So to make it a positive exponent, you take that, you bump it to the denominator of the fraction. You already had b to the 4th there, so it just goes next to b to the 4th. They're getting multiplied together. The 1 is now on the top because we moved the a to the negative 8 to the denominator. So 1 over a to the 8th, b to the 4th. Something is simplified when you no longer have negative exponents and when you have variables that are different that cannot be combined. Questions?
Whenever you're writing this stuff, like if you switch it down, would you go in alphabetical order?
Yes, yeah. Usually we write the variables in alphabetical order. Would I mark it wrong if they don't have it in alphabetical order? No. But yeah, A, B, C, D, writing them in alphabetical order is typically the way we would write it in like standard form. Other questions? So see if you can work on the handful of problems that are underneath. Then I think we have a little word problem to look at. Always got to throw a word problem in there. So evaluate means if it's a numerical value, you should have one answer when you're done. So you should not have any exponents remaining. Simplifying means if you have variables, then those variables you need to make sure you have no negative exponents and that all your variables, if they're the same, are combined. So Jillian, what do you do with that negative 1 on the outside?
You would distribute it, so you would have 8 to the power of negative 5 and 8 to the power of 32.
Then what do you think you do when they're both negative exponents? So I agree that this one goes to the bottom because now it's 8 to the positive 5. But this guy here still has a negative exponent. So right now, if we move the top to the bottom, it becomes 8 to the positive 5, the positive exponent, but we still have an 8 to the negative 2 remaining. What do you think you would do with that, Odette? Yeah, you move it to the top. So pretty much it goes to the opposite location so that it becomes a positive exponent. So if you currently have a negative exponent, you can't just poof, make it positive and keep it in the bottom. You actually have to move the location of the exponent. That's how it becomes a positive exponent. So 8 squared is now on the top, 8 to the 5th is on the bottom. So essentially they switched locations so that the exponent could be positive. Odette, what else could you do to continue to simplify that? So we can then take the 5 minus the 2, so you subtract the exponents from the biggest power, wherever it's located. And then the last thing, because this is a number, Odette, we can actually evaluate 8 cubed, which is 512. So that's actually a 3-step problem. Looks like it should be pretty basic. But we evaluate the power outside first by distributing it to the inside. We switched the exponents because they were negative. So the top power was a negative 5, it went to the bottom. The bottom power was a negative 2, it goes to the top. And then you can subtract those exponents. Questions? So for number 2, we have x squared and y to the negative 6th, and then that's to the 7th power. So Mackenzie Mallory, what would that become when you have a 7th power outside?
You would multiply the exponents in the parentheses, or the x to the 14th, x to the negative 47.
Okay, so we have x to the 14th, y to the negative 42nd. What else can we do? Emma, what else can we do with that problem? So we have x to the 14th, y to the 42nd, that's a positive. And then your final answer, Emma, is? And you can skip this step if you want to. So if you have 2 variables that are next to each other, next to each other, that one just goes right underneath the other variable. So x to the 14th over y to the 42nd. And then the third one here, this one's a little tricky because there's a number in front, there's a negative 2. And we have a squared and b. And then on the bottom we have a to the 5th and also b. what do you do with the exponent when it's outside all of that stuff?
Multiply
You multiply it to what?
all the exponents.
All the exponents inside. So if you look at all the exponents inside, the a has a squared with it. What's the b exponent? A 1. On the bottom, this b also has an exponent of 1. Abby, what's the exponent of the negative 2? A 1. Just because it's a number doesn't mean it doesn't get an exponent. So everything inside really has an exponent even if it's not written. Every number, every variable has to have a power. That 3 has to distribute to every single one of the exponents. All 3 of the powers on the top, also all 3 of the powers on the bottom. So the number also gets the exponent. Just because it's a number, it doesn't exclude it from having a power. So negative 2 is cubed. The a had a 2. We're multiplying 2 times 3 to get 6. The b had a 1. 1 times 3 is 3. So when there's a power outside, that power distributes to every exponent that's inside. In the bottom, it's also going to distribute to the 5 and the 1. So this becomes a to the 15th, and then again, b cubed. So the exponent outside distributed to every single piece that was inside. So now we have variables that are the same that we can simplify. And also the negative 2 cubed that we can do something with. So Holly, what's one thing you think you can do to simplify this?
Eliminate the b's.
Yeah, eliminate the b's. So b cubed divided by b cubed. Eliminate those b's. What else can we do, Holly? The b's are gone.
Cube
Okay, what is negative 2 times, or negative 2 cubed? Yeah, it's negative 8. And the last thing, Holly, we still have these a's to look at. What would we do with those? And 15 minus 6 gives you, say again? 9, yeah. So the larger power is in the denominator. You're taking 15 minus 6. That stays in the denominator. Wherever the larger power is where your variable should be located. So a negative 8 on the top, and then on the bottom is a to the 9. Questions? It was trickier than the other ones that we looked at. So the last problem here, it talks about a little bit of review of scientific notation. Does anybody remember like what scientific notation looks like? How do you write it? What does it mean for scientific notation? Connor?
It's like a number between 1 and 9.9.
So he said a number between 1 and, you said what, 9.9? Because it can't be 10. So a number between 1 and 9.9. We would write that number as c times 10, and he said a certain power. And that power we'll just say is n. So c has to be a number between 1 and, I guess you could say 1 and 9, from 1 to 9. And then we'd have that as times 10 to the n. It's allowed to be like 1.2, it could be 5.7, it could be 8.3, it could be 9.9, but c cannot be 10. So c is just a value in the ones place, and then there could be a decimal after it. So it says here, a swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in such a swarm? And then it says, write your solution in scientific notation. So before we talk about writing the solution or even just attempting to solve this problem, if you look at 85 million and the 1,200 kilometers, if you have 85 million, how could I write that number in scientific notation? So think we have 85 million. So we have 85, 1, 2, 3, 1, 2, 3. It's a lot of locusts swarming around. So if we write that in scientific notation, Odette, how would that get written in scientific notation?
8.5 times 10 to the 7.
Okay, so we have 8.5 times 10, and then she said to the 7th. So technically there's a decimal at the very end here, and you're just counting the number of times you're moving to get that decimal to be in between the 8 and the 5. Because that 8 has to be the number that's really from 1 to 9. So if you just count 1, 2, 3, 4, 5, 6, 7. So 8.5 times 10 to the 7th would be 85 million written in scientific notation. The other number is 1,200. And Odette, if we write that in scientific notation, it would be 1.2 times 10 to the 3rd. So that would be writing a number in scientific notation. So 8.5 times 10 to the 7th is 85 million. 1.2 times 10 cubed is 1,200 square kilometers. So the question says about how many locusts are in a swarm. So a swarm of locusts contains about 85 million locusts per square kilometer and can cover 12,000 square kilometers. So think, how would you find out how many locusts are in a swarm? That's what it's called, a swarm. What would you do with these two numbers?
Did you multiply them?
Yeah, we're going to multiply them. I want you to actually multiply them in scientific notation just because we're working with exponents. So I know you can take those big numbers and multiply them together, but we're trying to work with exponents, so let's see if we can just kind of multiply them as they are. So we have 8.5 times 10 to the 7th. That's one thing that we're looking at. That's scientific notation. So that's how many locusts are in a square kilometer. However, we're talking about an area of 1.2 times 10 cubed, or 1,200 square kilometers. So when you multiply these two together, and you'll have some homework problems that just are like this, and they'll ask you just to simplify the scientific notation. You're going to multiply the pieces that are the same, the like terms. So multiply the 8.5 times the 1.2. Abby, what is 8.5 times 1.2?
10.2.
And then we have 10 to the 7th and 10 cubed. So if the base is the same, Abby, what would you do with those exponents?
You add them
Add them. So this would become 10
to the 10.
to the 10th. So you're multiplying the parts that are the same. So the numbers in front get multiplied together. The exponents, when you have an exponent and the base is the same, you're adding the exponents. This answer, is it in scientific notation, Connor, based off of what you told us about scientific notation?
No.
So what would you do to get it in scientific notation?
Move the decimal place over 1 and add another power.
Right, so the decimal place needs to be moved over one more time. And we need to add an extra power to it. So this number in front is from 1 to 9. It's allowed to be 1, it goes up to 9. Anything after that is no longer in scientific notation. So 10 is really 1.02. 10.2 is really 1.02. And then times 10 to the 11. And this is, let's label it because it's a word problem. So scientific notation, that number in front is from 1, including 1, up until 9, including the 9 value. Makes it a lot easier to write numbers instead of writing all the zeros. So the homework for this evening is in the book. The last couple of problems will deal with just simplifying scientific notation. So it'll already be written for you. You'll have to be adding or the exponents or multiplying the numbers in front. You might be dividing and subtracting the exponents. And please make sure you write the original problem. And you have work for those that need work. Don't just write a wonderful answer that goes with no supporting work. And how about 2 volunteers? Let's see here. Want somebody to do 23 and 35. Maggie, you'll do 23? And somebody else, 35. Eden, 35. So remember, the assignment sheet was sent through Remind last week at the beginning of the week. It's the same assignment sheet for this week. We'll have a little quiz on Friday dealing with simplifying exponents. Just be like a short 5-question quiz. So it'll be similar to the problems that we worked on. We're going to do more with exponents tomorrow. And then Friday, short 5-question quiz on simplifying.